Here we are in TBS format, and as you can see, sorry for the low light, I'm not sure I can change that on the fly, I can't, but there you go, that's 500 diagonal, 37.5 on the lengths, a little shorter on the back, as a TBS is as well, but it's fully adjustable, so you can move these actually further back. And these are 10-inch props, so you have clearance of the lens on a GoPro, battery on top. These are the new 2215 motors that we'll be trying out with the new flight controllers. And the wires all run internally, of course. I have planned the ESCs to be right in here, one, and then back here as well, out of the way of the rotation. And there's all kinds of places you could put them. You could put one here, you could put one here, since we're not going to use the center as a battery container, but as a protective unit for the actual flight controller and electronics. The G10 will be either on the bottom or the top, depending on where you want your RF transparency the most. And I would suggest probably putting it on the bottom so that you can have your antennas on the bottom, not reflecting too badly, and have your clover leaf off the back probably or something, or off the bottom. It depends which way you want to mount it. I've put a mount here that is about the size of a SMA connector so that you can put an extension wire in through here and then have your antenna directly in the center here. Now, someone said that the mounts might not be strong enough, but this is pretty much machined aluminum, and once it's clamped in place, it's very, very rigid. And with the throwing tests I did, no breakage, at least, around the mounts at all, which really surprised me for the G10 mounts. But I'll be using carbon fiber mounts, I think. I'm not totally sold on the G10 mounts yet. They are nice because they're thicker, but doubled up carbon would be almost indestructible. And as I mentioned earlier, I'm going to double butt the tubing. So there's going to be a little bit of a process at my end. At least the inside edge will be double butted with 18 mil internal, 1 mil, so we'll have 2 millimeters. Still be able to fill the wires through. But that will add structure to the tightening of these main components at the end of the frame here on both sides. I thought about putting a turned aluminum brace in there or a shell, but that'd be a lot of work, and we don't want this to be a $700 quadcopter. We want it to be an affordable, packable quadcopter that has features. So you'll be able to cut down your own tubes as well, and bring it down to 8-inch props if you want, or bring it down to 7 even. 6 inches will work. I've planned it for 6 inches. So it could be a sub-micro or a sub-medium size, just a bit larger than a micro quad, a little more stable for heavier cameras and stuff. And the weight still, like I said, is almost 600 grams lighter than a DJI flame wheel, all packed up with FPV gear. Now, somebody sent me this a long time ago and told me, whatever you do, do not make a folding quadcopter like this. It's a $45 frame from Good Luck Sucker, I mean Good Luck Buy. And it has rotation as well. No locking mechanism necessarily. And if you look at it, it uses 2 mounts for the rods, but only 1 mount actually screws on one side. So you still only have 2 points of mounting, which really is a bad design, I think, even if it has the extra rigidity. I'll be adding on a Lexan 1/4-inch piece between my metal mount here and here, probably, perhaps on the outside, and it will be attached to your rod when you get it to set the distance of the actual arm. Now, if that comes off, that Lexan piece, that's nothing to be too worried about. You'll be able to glue it back on, or just put it back on. But it will be a good way to line up the depth of your tubes inside the frame, and then you won't overcompensate the length of the arm or damage the geometry. So we'll have a stopper basically that you can feed it in through, and that will work a lot better. We're going to have also rubber washer, very tiny rubber washers in the clamps themselves to keep them from sandwiching together completely, where they will start to damage the CF tubes because it's hard to judge how much pressure you're putting on it. I'm not going to ask customers to use a torque wrench, so that is a precaution I'm going to build into it. You can see a little bit of whitening there. That was from one of the largest throws today, and it's just scratching on the tube basically of the epoxy. It's not damaging the carbon fiber, but with a little bit of clear coat or nail polish or black pen, that would disappear for those who want an attractive looking quad. But otherwise, this is going to be a real workhorse. I'm looking forward to packing it up, and I think that for people that are going to get really seriously into it, they'll want to put indicator marks. And in a future model, depending on whether or not it's worth the money to add the time, I might actually etch some degrees on here. And if somebody takes that idea, then you know where they got it. But an actual radial degree arm on here so that you can actually line it up exact. I did take a small scribe on the front today, and you can actually scribe a line right beside the aluminum block here, and then you can line up that scribe for a rough estimate of where you're going to. These are on full extension right now, so that's an easy setup. Set these up at full extension forward or at 90 degrees backwards, and set that as your determined fitting. You could put a square piece of metal across the front of your braces too, because there's a lot of room under here for putting in a straight rule or something like that. So set up your arms first, either in H quad or in this forward motion, and then measure from your fixed positions up here of these two motors, measure that, and move back to set your rear arms to whatever size you're trying to set. So if you want to set them shorter, then you would move them forward and move your motors out perhaps to match the width of the front. Then you'd be in a true H-copter format. And if you notice, there's lots of room between these props to move this closer together. So it's not quite extended as much, but again, it's going to be a really stable flight with this kind of layout, 500 millimeters, good filming platform. And the GoPro I'm going to get is going to go on the front and on the bottom there. With the new landing gear I just sent off to Waterjet, which are almost 125 millimeters, so you'll be that high off the deck when you're landing. So it should give lots of clearance. And those landing gear clamp on the tubes, so you'll be able to move them out to the motors or inside the body if you're carrying a super heavy weight battery. So that's the $40 quality you get. Good CNC work, not bad at all. Excellent cut edges and stuff, but just a feeble design. And all to save money. The plastic is just too weak. I also got high density nylon, black nylon standoffs. And they're the same thing the gem fan props are made of, so that's a really nice addition to the whole frame. Adds a lot of rigidity. There's also holes here in the center that you could add two more. If you're carrying super heavy load of a battery or something, I'd suggest one here and one here. Take these two and put them there. And there's also space back here, but this is your control mounting area. And CG is about the center depending on where you have your arms, but it's going to shift with the variety of forms that you put your HB8 into. So that's tonight's little bit of a rundown. It's getting closer. It's looking pretty good with the black motors. It's going to have the black gimbal as well. Don't know if I'll have a black battery, but at least it'll fly. So there you go, HB8, today's update. And countdown for new shipment of carbon fiber HB7s and HB8s has begun.